This question relates to one of the reactions of aryl diazonium salts. Normally, when aniline is converted to benzene diazonium chloride, this can be subjected to a number of reactions to give a variety of products. There is one reaction which is known as Sandmeyer reaction, about which you have heard, in which when it is treated with cuprous chloride in the presence of HCl, this will give rise to chlorobenzene. When it is treated with cuprous bromide in the presence of HBr, it will give rise to bromobenzene. When it is treated with potassium iodide, this will give rise to iodobenzene. That is known as Sandmeyer reaction, that type of reaction. When fluorine is to be replaced, we make use of KHF2, which is known as Schiemann reaction. These reactions have already been discussed a number of times, has been discussed. But what will happen when this is treated with copper? Instead of treating it with cuprous chloride and HCl, instead of treating it with copper, what will be the product? You will get chlorobenzene here. Instead of cuprous chloride and HCl, this will give rise to treated with copper and HCl. This is known as Gattermann's reaction. Copper metal and HCl, this will give rise to Gattermann. This is known as chlorobenzene because copper and HCl is used. Assuming we make use of copper and HBr, then we are going to get bromobenzene. So we get bromobenzene with copper and HCl, and with copper and HBr we get bromobenzene, and when a small change is made in the Sandmeyer reaction condition, this is referred as the Gattermann reaction. This has to be distinguished from this Sandmeyer reaction, wherein you make use of cuprous halide, copper 1 halide. See, actually it is given as Cu2Cl2 in the presence of concentrated HCl. In this case, this is not known as Gattermann reaction, this is known as Sandmeyer reaction. Whereas CuBr and then concentrated HBr will give rise to the corresponding bromo compound, which is also known as Sandmeyer reaction. On the other hand, this treated with copper and HCl and HBr will give rise to chlorobenzene and bromobenzene, which is referred as the Gattermann reaction.